as well. So I'm going to get that out of the way. If you go to the lab section, actually the lecture has actually a link to labs. The lecture folder has a link to the lab materials as well. If you go to either one of those folders for tonight, there's a file that has data about the passengers on the Titanic, and it's actually an Excel file. And we're going to, number one, we're going to take that Excel file, import it into SPSS, right, for starters. Then we're going to take the code book that's there also. And that code book is going to tell us how all that data is coded. So for instance, one of the variables is gender. Another variable is the passenger class, first, second, or third class. And then they're coded as numbers. Male may be 0 or 1. We don't know which one unless we open up that code book and identify it. So we're gonna code the SPSS file that we create by importing the Excel file so SPSS understands what all those codes mean. What 1 and 0 means for passengers, what 0 and 1 means in terms of like whether that passenger survived or didn't survive. I think there's ages on there. There's some numerical variable on there as well. So I'm going to get started on that. So first thing I'm going to do is I'm going to make sure I have the file. So you want to go on Blackboard, right-click on that file, Titanic.xls, I guess it is, or XLSX. Right-click on it, save it to your desktop, and do the same thing for the code book. There we go. I'm going to blow this up a little bit so we can see it. Okay, so this is what we mean by a code book. It's going to indicate to us what all the variable names are and what they mean. Variable name is reported name of passenger. Passenger class is 1, first, 2 for second, 3 for third. Age is a numerical variable, the age in years of the passenger. Sex is 1 equals male, 0 equals female. And survive is 1 indicates a yes and 0 indicates a no. Okay, a lot of times they're coded this way because if we're going to type something in here like first class, second class, or something like that, the computer is very literal. It's going to see it exactly as you type it in. So if someone types in first 1ST, someone else types in first FIRST class, then it's not going to be the same thing as far as the computer is concerned. So it's a lot more reliable to just have everybody type in a 1 and quicker to type in a 1 as you enter data. And then later on deal with SPSS in terms of identifying and coding what this stuff means. So I'm going to go ahead and open this file. First, I'm going to open the file that contains the data, just so you can see it, the Excel file. Okay, here's the actual Excel file. There's the names, the classes, ages, and so on and so forth. Each one of these in the Excel file, the first line happens to be the variable name. I don't know why it's called ME. That's the way the data set came together. Anybody have any idea why they might have used ME for the name? Maybe there's some sort of way they would reference names in England at that time. Passenger class, P class, age, sex, survive. All of these are legitimate SPSS variable names. Remember, it's got to start with a letter or a number. It's got to start with a letter. It can be alphanumeric, have any letters or numbers you want in it. Can't have spaces, can't have special characters. Okay, so all of these satisfy that. So I'm going to now import this. This is an Excel file or a text file. I'm going to now import this into SPSS. First thing I have to do is close the file. SPSS won't tolerate a file being open in another application. It won't let you load it. at least the version that I'm using will let you load it. So I'm going to start SPSS. How many of you guys are doing this along with me? Okay, good. Who's just telling me that the Mac version is slow, right? You're exactly right. It is a bit slow. Okay, so this is the opening window. You can click this to tell it not to load this template window in the beginning if you don't ever want to see it again. You just want to manage your own files and so on and so forth. I leave it loading just so that other students, if they see it come up, they don't freak out if it's not there. So once you have this window open, if I'm starting a Word document, normally I would close this window just to get it out of the way if it brings up a blank document. But in SPSS, if you try and close this, it's going to close the program as well. It will never operate without an open data file. Just another quirk of this program. So instead, I'm going to leave it open, but in the background, I'm going to say File, Open, and I'm going to open a data file. Before I go any further, I just want to show you that you can open several different kinds of files in SPSS. You can open a data file. I'm going to skip internet data for now. You can open a syntax file. Syntax is basically a programming language that's built into SPSS. You can open an output file, or you can open a script file, a text file where you can create programs as well, these text programs as well. So I'm just going to open up syntax for a second, because you can type instructions into that. Actually, I should have just said new syntax file. Okay, just going to open that up. And I'm going to type in, I'm trying to remember what the exact wording is. Let's see. SPSS license. Display license, I think it is. And I'm going to go up here to the top of this window. And there should be a run. I'm going to say run all. Okay, let's see if it works. If I got the right syntax. No, I must have the syntax wrong. Anybody know what the syntax is? Anybody here that's an old SPSS person? I guess not, right? Let me, when you're at a loss, there's always Google, right? Display, SPSS license. Check my syntax. Syntax editor, show license. Wrong word. Okay. Nope, don't need that. I'm going to change that to show license. And I'm going to type run. And an output window should come up, and it should show me what the license. Unfortunately, the table is a little bit squeezed together, so you can double click on it and open that a little bit more, but it'll show you the date that your license expires. If you do a new installation and it doesn't seem to be working right, it won't let you enter data and stuff like that. It'll let you open a window but not enter data. Check to make sure your license is actually current and working. Because instead of saying your license is expired, a lot of times some versions of Excel will just not work correctly. Okay, so just so you know about it, typically this is the 24th of June that this in 2018 that this version is going to expire. They give you about a 30-day grace period. So it will really stop working July 24th. Okay, just so if you run into the problem, you know that that's there. I'm not going to save that. I'm going to close all this. Okay, so let's import our file again. I have to have an empty data file in the background just to do this. Open data file. And now that I want to open my data file, I have to navigate my way to the desktop, to the folder that I have it in, and subfolder that's listed in. And I don't see it there because it's an Excel file, and right now it's only looking for SPSS, SAV files, data files. Okay, so I have to let it know, look for an Excel file. Either look for an Excel file or look for all files. You do that instead. So it appears. Here's the Titanic Excel file. And I'm going to say open. And now it's going to come up with a window that's going to describe what it found in that window. And here you can see a picture of kind of what it sees.
It sees percentage of values that determine data. There's some missing values in there. It's not 100%. Ignore hidden rows, columns and rows, the empty columns and rows. That's true. That's what we want to do. There is one thing that's important, a couple of things important. The worksheet says that there's data between A1 and E1314. That's telling you that it found data between column A and column E, right? So row A and column E are five columns of data, and there were 5 variables. So we know that we're in the right ballpark there. It's also going from row 1 to row 1314. If you know that there's that many cases in there, which there are in this particular case, if you know that there's that many cases in there, then you know that it's getting all of the data that's in that file. Okay, and the next thing we want to see is that this first row over here with a check mark. Read variable name from the first row of data. Remember that Excel file? I checked to make sure that I saw what was in that first row, and what was in that first row was not the names and the data for the cases. It was actually the names of the variables, P, class, gender, and so on and so forth. I'm going to make sure that that's checked. If I don't check that, it's going to assume that that top line is data, and it's going to include those variable names in there as data, which is not going to make any sense at all. If I do check it and it isn't data, it's going to take a data row, like a person's data, a case, and move that up and use it as variable names. So we don't want to get that wrong. Click OK, and it's going to go ahead and import it. How many guys are up there with me? Yes? Okay, good. Yes? Any issues so far? The Excel file, it was already on my computer. I downloaded it to the desktop, and if you opened it online, you got 2 problems if you open it online. One problem is if you use Explorer, it opens in the browser window. It's not really open in Excel, so it's not really an open file in Excel, right? If it does open in Excel when you double click it, you then have to say save as and save it to the desktop. The alternative I like better is just to, while it's on Blackboard, right click, save file as, and drop it onto the desktop of the computer that you're working with. Okay, that way you have it on there. You don't have to worry about being on a network.
What's the difference between file import data Excel versus file open data?
File. Let's take a look.
You did file open.
Yep.
And then data. But import data, there's an Excel.
Let's take a look. Excel. Okay. The only difference that I see is
it's a shortcut.
Yeah, exactly.
Oh, okay.
I didn't have to tell it that I'm looking for Excel files. Okay. Right. So that, as far as I can tell, that's the only difference. It is possible that there are more versions. For instance, if you import SAS files,
it's going to look for these typical PostScript for SAS files, and it may be a little bit more efficient in importing it possibly. But as far as I know, from my experience, the only difference is it saves you changing the file type to search for it. Okay, so this is what we have. Now, if I'm again, the data view, if I go into the data view, look at this, I have all the data, all the names of the individuals. I have the class that they were in. I have their ages. I have the genders. I have whether or not they survived or not. Now, if you look carefully, it's all uncoded. It's all ones and zeros and so on and so forth. I don't really actually know what I have. So in order to identify for SPSS and for myself, so I can see what this data really means, we're now going to go in here and code this data. So the way I do this is I can flip back and forth between the data view and the variable view. Okay, the variable view, in the data view, the columns represent the variables and the rows represent the individual cases. In the variable view, the rows each represent a variable. Each one represents a column. So there are 5 columns in the data view. There's going to be 5 rows in the variable view. So the first row is the variable name ME. Doesn't mean anything to me at all. However, that's the person's name, passenger's name. So in order for me to describe to SPSS what that means, I'm going to go in here and go across. Well, type string variable. Like a string variable is a variable that contains letters and numbers only, no special characters.
So a name would be a string variable. SPSS guessed at that by looking at the variable as it loaded it in. But it looks right to me, so I'm going to leave it that way. The width is 62. It said I'm going to reserve 62 characters for those names. Why did it pick 62? Normally, it would only pick something like standard number, like 20 or something like that. But there are long names in there. So it took a length that was at least as large as the longest name that was in there, right? So you could, if you want, change that to 70 or 80 or whatever. You can't make it, if you make it less than 62, you may wind up truncating a name. So I'm going to leave it at 62. No decimal places because it's not a number, so you don't have to worry about that. Now in the label, this is your opportunity to put in a description that's better for someone to read or for you or someone else to understand than the variable name, than ME for name, whatever reason ME is there. So I'm going to type in here. You can type in anything you want, but I'm going to type in here passenger name. Okay, so that's going to be our label. So any kind of most of the time we're not going to really be using real subject names when we're dealing with data. But for the purposes of this file, it happens to be there, so I'm just not going to bother to delete it. I'll leave it there. The next row, the next entry is P class, passenger class. So I'm going to go across here, and it says, let's see, it's a numeric variable. It only saw 1, 2, and 3s in there, so it's going to say, gee, that's a number. Well, yeah, it's a number, but it's going to represent something, that number, but it is a number. And it says, well, I'm going to make the width 1, right? It defaulted to a width of 1 because it saw that there was nothing that was bigger than a single-digit number. That's okay. No decimal places. Notice there were no decimal places. We don't plan on using decimal places because that's really a category. Those numbers really represent categories. But now I have an opportunity to label this. So I'm going to type in passenger class. Right? Now, then I'm going to go across here, and I'm going to take a look at this column called the values. Now is our opportunity to take that categorical variable and identify it for SPSS. So I'm going to click into the cell for passenger class values, and you'll notice a little gray box appears on the right-hand side. Can you guys hear me in the back? Good. Okay. I have trouble hearing back there because of that noise from the fan. So I'm going to click on the little gray box that appeared there, and it gives me an opportunity to enter this in a window. So what does the number 1 represent? Number 1 represents first class. I'm going to call it first class. Number 2, label represents second class. And I'm going to click add to make sure it adds that variable name. Number 3, but they still call it steerage. I guess in those days they would call it steerage, right? So I'm going to call it third class steerage. Okay, I hope I spelled that right. I have no idea how to spell steerage. Okay. Okay, so we've identified those numbers for SPSS. So now if we create a table or a graph, instead of saying 0, 1, 2, or 3 for the class, it's going to describe the class using those names, right? A lot more convenient to understand. Now in missing variables, it's going to, basically right now it says no missing values, so I guess it didn't find any missing values for that particular variable, but even if it did, it generally, when you do calculations with numerical variables and so on, it just ignores missing variables unless you tell it to do something special. It is possible for you, if you want to code the reason for a missing variable, because that you're going to be concerned about why it's missing later on, you can code it. For instance, you can tell it that the number 99 represents people that you didn't know it because they weren't on the passenger list, or number 999, people refused to answer that question. And number 9999, they didn't know the answer to that question. So you can code why the data might be missing. For our purpose, we're not going to worry about that. Columns is going to be the number of rows in the display on the data side that you're going to allow to be visible. So passenger class, first class, second class steerage. 10 columns is plenty for that, because none of those descriptions. Actually, one might be. I'm going to make it 12. Usually, you can leave it up to SPSS to deal with that. Alignment is going to describe how it's going to align on the data side. Left alignment, right alignment, center alignment. Just so you just can work with the data in a way that you feel more comfortable. Now, measure represents what kind of variable it is. What kind of variable is passenger class? Is it numerical? It's a categorical variable, right? Even though it's represented by a number, it's a nominal or categorical variable. So let's talk about variables. What kind of variables do we have? This is important because SPSS is only going to be able to do certain operations with certain kinds of variables. So you have nominal categorical variables, things that describe something that you count. For instance, like number of siblings, or hair color, or a characteristic that you would identify with a name. Okay, like passenger class. What other kind of variables can we have? We can have numerical variables, variables that are on a scale or a ruler, so that we can have something that starts from 0 or 100, goes up to 1,000, and can have a lot of values in between. Age, weight, blood pressure, blood sugar, so on and so forth, all numerical variables. Numerical variables are special because since they're numbers, we use certain kinds of descriptive statistics. So it's important that SPSS understand that the data that's in that slot is numerical data so that we can do that right kind of statistics on it later on. Okay, so we got nominal or categorical data is one possible class. We have numerical data. Well, within numerical data, we kind of have a subset called discrete numerical data. What's the difference between discrete and just numerical data? You want to know something? Not that much difference. The real thing, the thing that's different is that the discrete numerical data can be described in units. So it's not going to have decimal places, number of siblings. You're not going to have half a sibling. You're going to have 3 siblings, 2 siblings, and so on and so forth. Where numerical data can have values in between. If I asked you what your age was, and the data, like it's on, the data might be, 62, 65, 63, 67, 62. Those are all integers, right? But, age is not an integer. It could be 62 point. There's values in between. They may be rounded to 62, but in reality, they can have values in between. That's the real difference between discrete and not discrete. Okay, siblings is not going to have 3.1 siblings. Someone's not going to have 3.1 siblings. When you look at averages, and say the average number of siblings that a person has in the United States is 2.17, well, an average is different because that's derived from many discrete values. So that's not a discrete variable. So you can have values in between integers, then even though they may not be displayed or described, it's not discrete anymore. So you have numerical variables. In fact, SPSS really doesn't bother to make a distinction. It only gives you 3 choices: categorical, scalar, which is a numerical variable. Anybody want to guess what the third one is? Ordinal, right? And an ordinal is a categorical variable, categorical variable. It's a category: good, fair, poor. But the distinction between that and the other categorical variable is it has order. In other words, fair is worse than good. Good is not as good as excellent. Excellent is not as good as best ever, right, or whatever. So it has relative order. That doesn't mean that that you can really quantify what the amount is or that they're equal. For instance, on a pain scale, how much pain are you in from 0 to 10? Oh, well, I'm in 7. Well, one person's 7, maybe a different person's 5. So they're not really comparable. And if a person now is 7 and they take aspirin and now they're a 4, right? Well, it went down 3, but you really can't prove that 7 less 4 down to 4, that difference of 3, is the same amount of pain reduction as going from 3 to 0, for instance, right? There's no way for you to really measure that or categorize it, but it has order. So that's ordinal data. So if I go in here, I have my choices to define this as scalar, ordinal, or nominal. So I'm going to leave it scalar. So I'm going to go to the next one, age. Age is a numerical variable. That's it, just a number. And I'm going to go down to the end just to make sure. Oops. Nominal? Yep, nominal. I'm sorry. You want to know something? It is ordinal, isn't it? Yeah, let's put ordinal in. Yeah, let's put ordinal in just for the hell of it. Okay, scalar. Okay, the age is a scalar variable. Okay, gender is a nominal variable. Survived is a nominal variable. It's a yes or no. Okay, so let's go back. Let's back up here to our values for our age. Age, we're not going to put in values because they have their own values, but I am going to put in here age. Okay, don't always have to change the variable name. And under sex, I'm going to get a little fancier. I'm going to put in gender. Okay, and I'm going to put in the values. Now, how do I know what the values are for gender? Yeah, code book. What is it? Okay, one is male and oops. Now notice female. Okay, notice if it'll let me say okay here, but it warns me, hey, you didn't really code that. You didn't put add. 0, female. Okay, now it's coded. And for survived, I'll put survival for the variable name. And the values, 0, what is it, 0 and 1? 1 and 0, 1 means yes, they survived. Okay, so I'm going to go in here to values. I'm going to say 1 represents survived. And 0 represents did not survive. Okay, good. All right, so now let's go to the data view and see what we have. Okay, one way for me to go back and forth between data view is to go down here on the bottom and flip back and forth. The other way is to go into the view and toggle down at the bottom here between data view and variable view. So I can do that either way. Okay, so let's take a look at it. Now it actually shows the passenger class. It shows the gender. It shows who survived and who didn't survive. It shows that shows the passenger's name, age and name, and so on and so forth. And if I don't want that to be shown, I could go up to View and tell it to turn off the value labels. And it goes back to the ones and zeros. Or if you open up a file and you notice it's just ones and zero, and you know that the file has been coded, you can just go back up there and turn the toggle for value labels back on, so you can see it again. Okay, so now that we've got all of this stuff, now let's put it to work. Okay, so the first thing yes. They're missing, right? That's okay. When we look to find an average or something like that, it's going to ignore the missing values. It won't count them. It won't count them as 0. Okay? So we don't have to worry about that. When we move on, and you want more sophisticated ways of dealing with missing values, for instance, why don't we know the name of the age? Did the patient refuse to give us their age? Did they not want to disclose their age? Did we forget to collect that information? Is it illegible? We might be interested in coding this in a way that someone can go back and figure out why is that data missing. It might be relevant to the study to know why certain data is missing. We may, if there's a special reason why that data is missing, we may not want to include that in our data set. We might want to eliminate all those that are coded 99 or I'll choose something else, 999 for age, because that has a certain reason for being missing, right? So later on, we don't have to worry about that right now. Later on, we'll take a closer look at that. But for right now, all you need to know is that if there's nothing in that box, it will ignore it. It'll just act as if that person doesn't exist for that calculation. It'll still do the other calculations, right, for gender and whatever else you want to look at. Okay, so now that we have all this data put together here, how do we actually go about analyzing it? And the reason, and if you think about it, the simplest way is if they had a tag up here that said analyze. And look at that, they have a tag that says analyze up there. You're gonna, almost everything you do is gonna go back to that one drop menu from the top. Okay, so we're gonna go up to analyze. And the first thing we're gonna do is we're gonna say to ourselves, let's take a look at some of the categorical data. Categorical data is fairly simple stuff, right? So when you're working with categorical data, like for instance, I want to know how many males and females were passengers on this ship, right? So it's categories, right? So how are we going to do that on this data? Well, you just simply count the number of males and count the number of females. When you do a count like that, it's called a frequency. So if you look in here, analyze, descriptive statistics, the statistics that describe the data. Descriptive statistics, you have a number of options here. Frequencies, descriptives, explore, crosstabs, so on and so forth. Well, frequency is pretty straightforward. It's just going to do simple counts. So I'm going to go to descriptive statistics and frequencies. It's going to pull up a box. Now, almost universally, when you do an analysis in SPSS, it's going to pull up a data box where you can choose the variables and the options that you want. Remember I mentioned that there's a syntax, a written language in SPSS that allows you to do all sorts of individual calculations, analyses, lets you do repeated ones by writing a script that you can run it over and over again if you need to do it. One of the reasons for that is that analyze drop box, that drop menu for analyze, it has almost all of the very commonly used analyses and options that you might want to work with on SPSS. But you want to know something, in addition to the options that are available in that menu, there are other options and analyses that are buried in here that are not included in that. So if you're a very sophisticated SPSS user, none of us will do this. At least not this semester, we're not going to be doing this. If you're very sophisticated, then you may want to write a syntax because you may want to get one of those special options on the various analyses. But for the most part, we're going to be able to get what we want from these boxes. So the first thing that we need is we want it to tell us this information. What variable do we want to find out this frequency count for? So I think I mentioned gender, right? So I'm going to move gender into the variables box. And what are my options here? Statistics. One of the other characteristics of SPSS is it won't always keep you from making a ridiculous mistake, right? So for instance, gender, mean. Do I want the mean for gender, average gender? Right? What does that mean? Does that mean like one testicle and one breast or something like that? It's meaningless, right? Gender doesn't mean anything. As far as it's not a numerical variable, doesn't mean anything. So you don't want any of these anyway. So I'm going to ignore them, leave them unchecked and ignore them. You can create charts, like a bar chart, for instance. I'm going to go ahead and click that, right? Just for the hell of it. You can create that chart using frequencies, the actual numbers, or percentages. I'm going to leave it the actual numbers, frequencies for now. I don't have to create a chart if I don't want to. You have formatting, style things, and so on and so forth. You can select. And a checkbox here, display frequency tables, which is really what we're after. A table that shows the frequencies, the number of males and the number of females. Okay, so I'm going to click OK. When I click OK, what's going to come up next? It's going to create an output window for us. It's going to create a single output window for all of the analyses that we do from this point forward. All of them are going to be in the same window. Every time we do a new analysis, it's going to be added to the bottom of the previous analysis, right? That's kind of convenient, almost like a ticker tape. Remember they used to have calculators with tickers on paper come off of them? Yeah, you people are too young to remember that stuff, right? Right? You do remember. Yeah, I'm not making this up. They used to have calculators. Oh, they still have them, like in the quick stop across the street or something like that. They'll have that. Like the ticker will come up. Okay, so it'll do the same thing. It'll just add one analysis to another. And what do we get? There we are, gender. And what do we got there? So you guys are doing this too, right? So here's the frequencies. We have 462 females, 851 males, 1,330. This is the percentage of males and females, 100%. Valid percent, this is where we would see the difference between where they might be missing values. We would see the valid percent would be under 100% because they're missing values. Okay, cumulative percentage and so on and so forth. Here's a nice bar chart that shows up, and notice the y-axis is frequency, the number, right? So in other words, you could get a rough idea of there were considerably more males on this voyage than there were females. So at least that we have data for. Okay, so let's do that again. Analyze, descriptive statistics, frequencies. The only thing I'm going to change is I'm going to go back into charts. And I'm going to tell it, do it by percentages instead. I'm going to click continue, say OK. The same data box will come up again, right? With same data, except this time the chart, the abscissa, the y-axis is going to be percent. So it's going to be about 38% versus about 62% or something like whatever the converse is, right, for male and female. Slightly bit different shape because it's percentages rather than actual numbers. Okay, so what about, is there another way I could do this? Analyze, descriptive statistics, frequencies. Okay, this time I'm going to go back in the charts. I'm going to say make a pie chart instead. Say continue, and you know something? I'm going to put survival in there as a second variable. Okay, you can load up this, you can put even more in there, passenger class. I'm going to move that in there, and I'm going to click OK. Okay, and what does it give me? It gives me 3 separate boxes for gender, for whether or not a person survived. Among these, among this, 65.7% did not survive. 35% did survive. And there's the percentage by gender. There's the percentage of survival. The green part was survived. The blue part was not survived. And here is the passenger classes, right? And there's a lot more third class steerage than there were for first class and second class people on this boat. Okay, so we get kind of a picture of what this data looks like. They say, or they used to say, I don't know what they say anymore, but they used to say a picture is worth 1,000 words, right? A lot of times it's a lot easier to communicate. Don't laugh at my old expressions, okay? They're going to get worse, trust me, as we go on through the semester. There's a lot of instances where you'll find where describing data graphically is going to communicate it a lot more easily, a lot quicker interpretation than displaying it in tables and numbers. We're going to be, statistician may be focused on tables and numbers, but sometimes when you want to put together a report, you want to communicate information effectively. It's nice to use a technique that'll communicate it very clearly and simply, okay, like graphics. Okay, so that's categorical data. Okay, so I'm going to go up here to analyze, descriptive statistics, frequencies, and that's where I'm going to work with my categorical data. Well, now, what if I want to work with numerical data? Let me see what time we got here. Now, what do I want to? Let's say I want to know something about numerical data. The only numerical data we have here on is age. So I'm going to be working with age, obviously. What might we be interested in terms of the age on here? Might be interested in the way it's distributed. I might be interested in what the average age was. I might be interested in how variable the age is. How's the youngest? How old is the youngest? How old is the oldest? Okay, so let's think about this. First thing I might be interested in is where's the middle? What's the average age? So what measures do we have for average age? We got mean, median, mode, right? Those are 3 things that are measures typically of the middle. Mode's a little tricky, right? Because it's just the most frequent value. Mode may not be very interesting here because mode, when you're talking about age, it's going to tell you what age was most frequent. So let's say you happen to have a lot of 17-year-olds on this boat. The mode might be 17 just simply because there's so many other ages that it really doesn't really represent too much. But median and mean are important to us. The median really tells us literally the middle, because over the 1,300 passengers, it's going to sort them by age, and it's going to give you the age for the 650th passenger, right? Actually, the way physically we would calculate it, if there were 10 people, if there were 11 people here, it would give you the age of the 6th person, the middle person. 5 below them, 5 above them. If you have an even number, like 10 people, it's going to take the age of the 5th person and the 6th person and average it, and that's what it would calculate as your mode. Right? So you might have integers for age, but you might wind up with if it's an odd number of people, you're going to wind up with a fraction for the median. But the mean is going to tell you really where the middle is. What about the mean? Well, if it's normally distributed, in other words, it's evenly distributed above the middle and below the median, the variability is not an unusual number of kids, not an unusual number of very old people. If it's really normally distributed, you would expect the mean and the median to be about the same. Well, what does it tell you if the median is, say, 40 and the mean is 30? They've been pulled apart. And the mean has been pulled down. What would pull the mean down away from the median? A lot of younger people. In other words, there's data on the low end that's forcing the mean away. And we call that skewing. So when the mean is pulled to the left, of the median. We call that skewed to the right. Okay, I have to turn around and actually look for the right to figure this out. Right? It's skewed to. I'm sorry. It's skewed to the left. Right, exactly. It's skewed to the left. I'm going to do it from your perspective. This is the low end, this is the high end. It's skewed to the left because there's a lot of younger people. A lot of older people clustered here, then the mean is pulled to the left, to the right, your right, and that's called right skewed or positively skewed. If it's pulled lower, it's called negatively skewed or left skewed. If it's pulled above, it's positively skewed or right skewed. Okay? And if you looked at what the median, I'm not set up to really draw this right now, but if you looked at that distribution, if it's skewed to the left, you'd see it narrow here and then wide, and then there'd be a lot of people on the low end here, a lot of children there, and if you skewed it this way, there'd be a lot more older people up here. You have a big tail on the right side for the old people, or on the left side. At some point when I can get a chance to actually draw this for you, or maybe I can go back to something in the lecture and show you some pictures of that. So that you'll be able to recognize skew from that. Okay, so what about variability? What are our measures of variability that we might be interested in these numerical variables? What's the most obvious? Range, right? What's the lowest number? What's the highest number? It's our range. Okay, well, let's see. What else might be interesting that might give us a view of the variability? What was that statistic we calculated last week that was a measure of variability? It was standard deviation, right? Standard deviation is a measure of variability in a normal distribution. What else? There's a graph that you were just looking at that measures percentiles, right? What's that? Box plot, exactly. And the box plot measures for you percentiles. So if we look at the box plot, the bottom end of the box plot is going to be the youngest passenger. Top end of the box plot is going to be the oldest passenger. So there's our range that is represented. There's a box in the middle with a black bar in it. That black bar in the middle is the median. And that box, one end of it is the 25th percentile. The other end of it is the 50th percentile. So between that feather on the bottom and the bottom of that box is 25% of the passengers. Between the bottom of that box and the end of that box is the middle 50% of the passengers, the ones below the median, above the median. And then from the top of that box to the other feather at the end is the top 75%. Okay, and it's literally just as if they were ordered by who is the highest, next highest, next highest, next highest, next highest. You take the GREs. If you get a score of, I don't know how they grade it these days, but if you get a score of 1600, you might be in the 93rd percentile, which means 93% of the people scored lower than you, 7% of the people scored higher than you. If you saw a box plot for the GREs, that bar in the middle would be the 50th percentile. Half the people scored less than that, half the people scored above it. We'll actually create one now. So I'm going to go, now I want to do a different kind of analysis. I'm going to go into descriptive statistics, and I'm going to go into descriptives. Okay, and this time I'm going to take my numerical variable, move it into my variable box. Okay, and I'm going to click on options, and now I'm actually going to use these various kinds of calculations. I'm going to calculate the mean. I'm going to calculate the standard deviation, the variance, the range. Okay, and I'll start with just those. I'll click continue. And I'll say, okay. SPSS is going to take all 1,314 of those values, and in about a second or two, I'm going to squeeze this up so I can raise it. Okay.
So you checked mean, standard deviation. Which ones did you check on the option?
I checked everything that would apply: mean, standard deviation, variability, variance, range. Actually, you'll be able to see it right now. Unfortunately, it doesn't let me expand the window the way most programs do on the Mac. Okay, so here we go. The number of people that we have valid ages for, 756. We didn't have ages for all the passengers. They probably wasn't, logged because they don't know their ages. Okay, the range was 70.83. That tells us you subtract the oldest person from the youngest person. It doesn't tell us it's the youngest and the oldest.
Eldest, the youngest to the oldest. Okay, 71-year difference between the oldest and the young. Actually, it does. The minimum age was 0.17, which I guess would be 3 months or something, 2 months or something like that old. And the oldest person was 71 years old. The mean age was a little over 30 years old. And the standard deviation was 14. When we move on into the semester of the calculation, it's going to mean a lot more to us in terms of the distribution. And the variance was 203. Anybody remember the relationship between the standard deviation and the variance? Right. It's the standard deviation is just the square root of the variance. And if you multiply 14 times 14, you'll get the variance. Okay, that's interesting. But you want to know something? I'm really curious. What do you think? Do you think there's an average, the difference between the average and the variability in the age of people that survived versus people that didn't survive? That might be interesting to look at, right? We got a problem though. We can't this technique we just used, descriptive variables, descriptives, only gives us the data for the entire data set of ages. I need now to break that up so I get separated the variability the variability for survivors versus non-survivors. Let's take a look if I can't do that. So now I'm going to go up to Analyze, Descriptive Statistics, and instead of going to descriptives, I'm going to go a step down to Explore. It's also going to give us descriptive statistics, but it's going to give us more options. Okay, again, we're always going to the same spot. Dependence list. They kind of threw a new name at us. Dependence is going to be the variable that we want to work with. And the variable we want to work with is age. And the factor list. What does factor mean? When you factor numbers, what are you doing? For instance, if I want to factor 10, I could factor it into 2 times 5, right? You break it up into its components. So we want to take age now and we want to factor it into different survival categories. So I'm going to put survival into that factor category. So now it's going to separate the data. This group of ages is people that survived. This group of data is people that didn't survive. And now we can tell it to do the calculations that we want. Statistics. Now notice it's going to, by default, it's going to do a lot of, we're going to just check off descriptives. It's going to do a whole litany of descriptive statistics on its own. There's also something in here, confidence interval for the mean. When we get into in about 3 or 4 weeks, we're going to be getting into understanding what that is. Many of you probably already know, but when we get to that point, we'll really get into that. So I'm just going to leave descriptives checked off and click OK and see what I get from it. Notice I didn't check anything for plots yet. Okay, and sure enough, I get some output. And in this output at the top here, and again, it might be easier for you to go to meeting even now if you wanted to and open a window there so you can read it from way in the back there. If we take a look at this, it's broken up. See, 51% didn't survive, which is 51% did not survive. And does that make sense here? Let's see. Did not survive. Did not survive. There's missing data. 61% of, you know what it is? Let's see what happened.
You gotta read horizontally.
Yeah.
To add up to 100.
Yeah.
So.
Yeah. So it's separated the percentage that did not survive. We don't want that. Don't worry about that. That's just telling us what percentage had.
Oh, it's
missing the data, right? I'll have to deal with that missing data later on. I don't want to deal with that right now. I was hoping to avoid that anyway. So let's just look at the actual calculations that it did on the people that it actually had. So the average age for people that did not survive is 31. The average age for people who did survive is 29. So the survivors were a bit younger than the people that didn't survive. What do you think that might be? Probably women and children first, at least for the upper classes anyway, right? Let's take a look at gender in terms of who survived and who didn't survive. But before we do that, let's scroll up a bit. And we get automatic charts that print out here. Okay, these are called stem and leaf plots. You're not going to use them very much. I don't want to run out of time tonight before we get to some other stuff, but I'll describe them to you in the future. Here's our box plots, right? So you can see that actually the ages are pretty similar for survival. didn't survive or survived. The average age is, the variability is similar. This group over here did not survive. It looks like it's skewed, doesn't it? There's a lot of values up there. The median is here, but there's a lot of values that stretch out up here. So it's skewed to the older people. A lot of the older people didn't survive. They didn't move fast enough to get to the lifeboats, I think. Yes.
Are those outliers?
Yeah, those are outliers. SPSS has a formula built into it by default for determining what an outlier is. And it determines that an outlier is 1.5 times the difference between the 50th percentile and the upper quadrant, right? So 1.5 times. At some point, it says, okay, anything above this, I'm going to define as not outlier. You can change that. In reality, it's leaving these out of the data set. You can change it so you include them, or you can make it even more rigorous, or you can individually choose to eliminate them and not use them in the data set, or use them in the data set based on why they're so extreme. So let's take a look. And these numbers represent it doesn't represent, for instance, 73 is not the person's age. That's the case number that's represented.
And if you look on there, you'll probably see what that person's age actually was. So at any rate, so let's see. So I'm going to go back here, analyze, descriptive statistics, explore. Let's do the same thing for gender. And I'm just going to simply move gender into the factor list. Click OK. And let's see what that looks like. Okay, what's the average age of survivors by gender? Let's see, females. I'm sorry, average age of females, I'm sorry, what did I do here? Nope, this is the average age of females and males on the boat, not survivors. Analyze, descriptive statistics, explore. Let me try this again a different way. I'm going to get to the comparative. We're going to get to that comparison, comparing categorical variables in a second, just before once we get off these numerical variables. Instead, I want to take a look at passenger class, what the average age was on this boat by passenger class, not survivor, but by passenger class. Okay, so first class, the average age was almost 40. Second class, the average age was 28. And third class, the average age was 25. A lot more younger people in steerage than there were older people. And a lot of the older people, a lot of the first class people were considerably older on average. Box plot should show that also. Here's the oldest group. Here's the next oldest group. Here's steerage down here. Okay, so you can graphically see what the comparison is between these groups. So let's take another look at this now. Okay, now I'm going to take a special look at this. I'm going to say to myself, you know, did more women than men survive? Is there a difference in the survival for gender? So I'm going to look at comparing gender and survival. Well, what kind of variables are both of those? They're both categories. Oh, well, gee, it's not. I can't use explore because descriptives and explore frequencies only just give me a simple count. Explore is really for numerical variables. The descriptives are numerical variables. I need a tool that will help me compare outcomes for different categorical variables. Like what was the survival rate for males and females? Well, I have that. It's going to be a while before we actually put this into practice, really. But for now, let's go in here and say analyze, compare means, descriptive statistics. And this time I'm going to go down to the next selection, which is crosstabs. And I'm going to click on that. What does crosstabs mean? Crosstabs is when you draw a table, sometimes we call it a contingency table, that has rows and columns. And most of the time, to make it easy to compare things, you put the exposure in the rows and you put the outcome in the columns. So for instance, cigarette smoking, yes and no in the rows, and lung cancer, yes and no in the columns. If you wanted to compare whether cigarette smokers get different rates of cancer than non-smokers, for instance. Well, we're going to compare that now The exposure is going to be gender, and the outcome is going to be whether or not the person survived or not. Okay, so in the rows, I'm going to move. Let's see. I'm going to move. The exposure is gender. I'm going to move gender into the rows, and I'm going to move survival in the columns. Okay, so for right now, I'm going to go into cells, and I'm going to tell it to just give me the observed values. That means just count for me and put it into these boxes. So I'm going to click OK, go ahead and do it and say OK. And what do I get? I get a box. Let me bring that up to the top. Again, I'm recording this now, so if you want to go back over it, you can't see this well from the back or something like that, or you're not following me along and doing it yourself. Hopefully, I'm hoping as many of you is following along and doing it as possible. What do I got here? Well, let's see. There were 462 females and 851 males. Of the 452 females, 308 survived. Of the 851 males, 142 survived. Not looking too good for the males there, right? Okay, let's take a closer look at this now. And let's look at this by percentage. I'm going to go up to, what am I going to go up to do an analysis? Analyze, right? I'm going to go into descriptive statistics, cross tabs, and I'm going to go into the cells. And I'm going to ask it, give me the observed values. Give me the percentages by row also. I'm going to click continue, and I'm going to click OK. And I get another box. Except in this box, see if I can't bring that up here so you can see it. In this box, it actually shows me, well, for females, the survival rate was 67%. For males, the survival rate was 16%. Whoa, quite a big difference, right? So when we move forward with this, the risk of not surviving for males is 83%. The risk of not surviving if you're a female is 33%. So the risk ratio would be 83% over 33%. It's almost 3 times as likely to perish if you were a male on this boat than if you were a female. There's another kind of calculation that's called risk ratio, right, or relative risk. There's another calculation that we can do with these numbers that's called the odds ratio. Okay, and a lot of times, a lot of studies, you will see the odds ratio or the risk ratio noted. Okay, and in fact, I can actually do that calculation from here. I'm really getting off on a tangent here. You're not really ready for this. This is something we're going to do later on in the semester, but I can't control myself. So I'm going to go in here, and I'm going to say go into cells, and I'm going to ask it to calculate, statistics. I'm going to ask it to calculate risk. I'm going to click OK and OK. And I get an extra column down here, which gives me odds ratio, which is 0.1. Okay, that odds ratio of 0.1 means 0.1 means being female is protective. You're 1/10 as likely to perish if you were female on this boat than if you were male on this boat. From risk ratio, the way we calculated it before, it was 40%. In other words, your risk was at 40% of the risk for males, which would have been 2.5 times. It's a little bit hard to interpret because the way we set this up, these columns and rows are not very, you can see did not survive is over here and survived is over here. It really would have been easier to understand if survived were here and did not survive were here. Why did SPSS put survived here and did not survive there? Yeah.
Did not survive at 0?
Yeah, it's an ASCII thing. It uses the ASCII character. It uses it does it alphabetically and numerically. In other words, if we had coded it so did not survive was represented by a 0 and survive was represented by a 1, it would have been reversed. It would have been easier. Our ratios would have been a lot more. You've been able to define them as an increased risk rather than something it was protective being female. Right? It would have been a little bit easier to interpret. So we're going to talk about all that stuff as we move on with the semester. Okay, so 7:45. So I'm going to stop now because I got to get to another class, And I know that you're going to stop me and want to ask me questions as you walk out. Okay, so I want to have at least 5 minutes with you guys before we do that. Do you have any questions? Yes. Like I said, I brought you a little bit ahead where you should be, but I went into analyze, always analyze, descriptive statistics, crosstabs, and inside the cells, I could identify what data I wanted it to display. But if I go into statistics, that tab says statistics, I can ask it to tell me the risk. There's the risk, the relative risk, the odds ratio. If I turn that off, it won't do it. If I turn it on, it will do it. There's other calculations here. We're going to learn about chi-square and so on and so forth. There's other things in here we're going to be using as we move forward. But that was just an easy way to get to that particular calculation. Is under one of those buttons, one of those options. Okay, guys? Okay. It's not hard, right? It's like riding a bicycle. Now go home and actually play with this. And like I said, I'll post a reminder about that online session on Thursday. Post questions to the forum, to the discussions forum, or email me if you want me to address them.